The purpose of this video is to help you become familiar with the data that I analyzed that we collected in the field during our ecosystems field trip. So I've posted the data in an Excel spreadsheet for you. There are multiple pages. The first two include all of our overstory data. One of the tabs includes all of the data. The other includes all the data minus one group's data because we had some misunderstandings about what those data represented. So these are the overstory data that made it into the summary tables. You have one tab that has all of the raw abiotic data and one tab that includes all of the raw understory data. So these data are available to you if you need to refer to them or if you want to do some other analyses. I've put the data that I've analyzed into these summary tables on the Summary Table tab. And I want to point out that we have 4 habitats here. We only sampled 2. So the data from the other 2 habitats is coming from the spring 2015 botany class. So the first table here represents the overstory data. And I guess before I get started, I should say that recall that a portion of your report is going to be your results section, which includes presenting the results in tables. So I've given you a head start on this part. I've created these tables that you can cut and paste and modify and put into your reports. If you choose to compare Eddy Creek to the COS forest, you're going to want to get rid of the other data that are here. If you choose to examine the communities along the elevation gradient on Mount Shasta, then you're going to want to omit the Eddy Creek data. And that goes for the overstory, the abiotics, and the understory. Okay, so let's start by making sure we have a good understanding of what these overstory data represent. And we'll just take a look at the Eddy Creek data, but what we say here is going to be true for all of these communities. So you have the tree species here that we found in all the 3 points along the transect. So you've got the species names, and then you also have their densities. This is the total density of trees for that site. To calculate the total density, I took the average of the distance to trees that you guys measured in all 4 of your quadrants and all 3 of the plots that we have overstory data for. So I took the average distance, and to calculate the density, I took 1 and I divided it by that distance squared, that average distance to trees squared. So that's what this number represents, and you can see it's a relatively low density, and you probably noticed that when you were in that site. The density of trees was really low. Note that the units here is trees per meter squared, so we have 0.018 or 9 trees per meter squared. We also have the same, we also have density by species, so this would be the density of Jeffrey pine in those plots in trees per meters. This would be the density of incense cedar, and this would be the density of Doug fir. The relative density is the percent of trees along this transect that were each of these individual species. So 75% of the trees we encountered along that transect were Jeffrey pine, 16.7 were incense cedar, and 8.3 were Doug fir. The basal area I calculated using the diameter at breast height data that you collected for each tree. I converted those diameters to areas of the circles of the stems, and this is the total area, basal area of Jeffrey pines along that transect. So 27,283 centimeters squared. And this is the basal area for incense cedar, and then this would be the basal area for all of the Doug firs that we encountered along that transect. This is the total basal area in centimeters squared of all the trees we measured along that transect. The relative basal area shows us what the percent of the total basal area was represented by each species. So Jeffrey pine was 67% of 40,354 centimeters. Calissedrus decurrens, or incense cedar, was 11.5%, and Doug fir was roughly 21%. So hopefully that gives you a sense of what these overstory data represent. The same is true for the COS Forest, McBride Springs, and Sand Flat overstory data. They're all presented in the same way. Now let's take a look at the abiotic summary data. So again, we have data for all 4 of those communities. You're not going to present all 4 of those communities in your report. Depending on what you focus on, you're going to present just 2 or 3 of them. So this column, I tried to summarize the variation in soil texture that we found along each of their transects. This column is the percent soil moisture. So I calculated this using the soil cores that you collected and gave to me at the end of the day. So this is a percent that represents the wet weight of those cores. I weighed them right after you guys left. I dried them in a drying oven, and I subtracted the dry weight from the wet weight, so the difference. And then I divided the difference by the dry weight and multiplied by 1,000 to get soil moisture. So that's what these numbers represent. I'm not sure. So 2015 was a very different winter than 2017. So I'm not sure that you're going to want to make a lot of comparisons between our soil moistures in 2015 to what we found in 2017. So you might want to be careful about that. The light and lux, these are the data that I collected at each of your points using the light meter. I multiplied them by 10. So remember in the field at Eddy Creek, I was telling everyone our light meter was actually maxing out there at 2,000. But that's what it read, but it really was 20,000 lux. So all of these data probably look a lot higher than the numbers you remember me giving you, and that's because they were all an order of magnitude lower on the screen. So these are the data that we collected with the light meter. And those are what we have for abiotic data. And then finally, the last summary table here summarizes what we saw in the understory at Eddy Creek, the COS Forest, and then what my 2015 class saw at McBride Springs and at Sand Flat. So these are averages of your percent cover estimates of herbaceous plants. So we did 4 plots, 4 1 by 1 meter plots along the transect, and these are the averages of those 4 plots. These are the average species richness, and species richness is the number of species, number of herbaceous species. And then we have the same data here for woody plants. I then added up the woody and herbaceous understory plants to get total average percent cover and total mean species richness. So it's going to be your job in your ecosystem report to present and modify these data in tables in the results section, to write a narrative in the results section where you describe these results in words without interpretation. So you just kind of write a narrative of what the data are in the table. And then finally, in a discussion, you're going to interpret these data. Why do we have higher light in this particular place? And how does that affect the understory growth? So those kinds of things. Please let me know if you have any questions. I'd be happy to help you with this if you're feeling like you need extra assistance.